Look at number 1 through 4. Okay. What do all of the directions have? About the origin. Okay. What else do they have?
Numbers.
A number, right? They also have dilation. Yes. They have a number. What is that number? Does anyone know what did you say? What were you about to say? Yes. Okay, so that number on 1 through 4, I want you to tell me if it's going to be an enlargement or a reduction. So go on 1 through 4. I want you to write reduction or enlargement on all of them based on what the scale factor is. So if the scale factor is greater than 1, it's an enlargement. If the scale factor is less than 1, it's a reduction. So go ahead and write whatever enlargement or reduction is on 1 through 4. All right, so on number 1, the number or the scale factor they gave us is 2. Well, is 2 greater than or less than 1? Greater than, so that means it's an enlargement. Number 2, we have 1/4. So is that an enlargement or a reduction? Reduction. 1/2, number 3. Reduction. And number 4, enlargement. Okay. One thing someone else in another period said is, oh, so if it's a fraction, it's automatically going to be a reduction. Is that true? What if I have 3/2? Is that an reduction or an enlargement? Enlargement, why? It's 1.5, right? So it's greater than 1. So just because it's a fraction does not guarantee that it's going to be a reduction. Capiche? All right. Flip back to 1. We already know it's an enlargement, so that means what? It's going to get bigger, okay? So we can use that as a checkpoint. So I'm going to take each coordinate one by one. So starting with F, what is the coordinates of F on number 1? -2, -2. What am I going to multiply that by? 2. Where'd you get the 2 from? Exactly. Yep. You get it from the problem. That's the scale factor. Okay. So what are my new coordinates going to be? Yes, exactly. So when you multiply the scale factor, you're going to treat it as the distributive property. So I'm going to take 2 times -2, and I'm going to take 2 times -2. Okay, treat it as the distributive property. Once you get that, I would go graph it. Okay, now we're going to find G and H. What's the coordinates of G? 0, 2. What am I multiplying by? 2. That gives us 0, 4. Good. And then go ahead and graph that. And then last one, we have H. What are the coordinates of H? 2, 1. Multiply by 2 to give us 4, 2. Okay. Once you have that, go ahead and draw your image to check, did it get bigger? Yes. So our original thought is correct. It was an enlargement. Questions about that? All right. I want to look at number 3 next. So let's move down to number 3. We said that was going to be a reduction, so that means it's going to get smaller. Okay, so same thing. I'm going to start with V. What are the coordinates of V? -1, 2. What am I multiplying by? 1/2. Yep. Remember, you get that scale factor from whatever it's trying to dilate by. Times 1/2. What's my new coordinate then? -1 times 1/2. -1/2, and then 2 times 1/2 is 1. Okay. Now, notice when you have fractions, it is not going to always land on a perfect point, and that's okay. Okay? So when you graph this, you're going to estimate where that's at. It's going to be about right there. Hey, what are the coordinates of U? -1, -1, multiplied by 1/2. My new coordinates are... Yep, thank you. So then again, guesstimate where those points would be. And then last one, W is at 1, 1. So my new coordinate would be 1/2, 1/2. And then draw your new image. Did our image get smaller? Yes. Is that what we wanted at the beginning? Yes. Okay. One thing I want to talk about in comparing 1 and 3. Okay. What do you notice about the pictures? What'd you say? They're both triangles. Okay. If I'm looking at number 1, with the dilation, we went from a small image. That small image ended up being inside or fully inside our new image. Does that make sense? Okay. But look at number 3. Was that the case? Why not? Do we know why? Okay. So if we did a reduction on number 1, do you think that the image would fall inside the other image? It actually would. So what is the other part of the directions? About the origin, okay? So no matter where our image is at, it's always going to be related to the origin.
Oh, well, it just depends on where the triangle starts at.
Correct. Yep. So if my triangle started up here and we performed a reduction, it would end up closer to the origin. Does that make sense? So all of these are based off the origin. So if you were doing a reduction or an enlargement and you're like, well, my shape didn't land exactly inside or outside, that's totally fine because it's all based about where the origin is. Okay, so it's not always going to perfectly land inside the shape or perfectly land outside. Okay, it all just depends where the triangle is placed at. So do not use that as a way to check. Okay? I want to talk about number 2 because I see why number 2 can be scary to some of us because it's a 1/4 this time. We're going to still do the same thing. So what is my original P coordinate? -2, -1. What are we multiplying by? 1/4 because that's the scale factor they gave us. What is -2 times 1/4?
It's a half.
It is -1/2. Think of these as fractions. Okay, this would turn into -2/4, which we know is -1/2. And then what's -1 times 1/4? -1/4. Again, guesstimate where that would be on the graph. It does not have to be perfect. Okay. Q.
0, 2.
Thank you. 0, 2. What's any number times 0? 0, and then we have 1/2. Oh, that was supposed to say P. R. 1, 1. Multiplied by 1/4 gives us.
1/2. Or no, 1/4.
Yep, 1/4, 1/4. And then S. 3, 1. Times 1/4. My new coordinate is 3/4 and 1/4. So again, what should your images look like? Should they look like the original? Yes, just different sizes. Yep. And we said reduction right at the beginning. Were we correct? Yes. So that's a way you can check. Okay, I'm going to leave number 4 for you so you can practice doing dilations on your own. Okay, one more thing we have to talk about. What's 5 and 6 about? Writing a rule. Go ahead and flip to the back. 5. Okay. What was step 1? Find which one's the original, and then we need to say if it's an enlargement or reduction. Inside or outside? Inside's my original, so we're getting bigger, which means enlargement. So enlargement. And then we need by whatever the scale factor is. So how do we find the scale factor?
Find both the coordinates, like each coordinate.
Yep, doesn't matter which point I choose. No, it should be the same. Which point do we want?
J.
J. What is my new J coordinates? 0, 4. And then my old J is 0, 2. Now, does it help me if I do 0 divided by 0? No. Is the scale factor 0? No. Okay, can a scale factor be 0? No. So 4 divided by 2 is 2. So it was an enlargement by 2. So we had a dilation of 2. Okay? When you write these, this statement should match your scale factor. Okay? If it doesn't, you obviously have one of them wrong. Okay? Let's look at number 6. First of all, which one's the original? Inside. So it gets bigger, which means enlargement by, we need to find the scale factor. Okay? Go ahead and try and find the scale factor on your own. Which point did you guys choose to find your scale factor? Did anybody pick anything other than L? Why did you all pick L?
Because they're not halves. It's not on a half.
It's like a perfect point, right? That is what you want to do. You want to pick which coordinate or which letter has the perfect point, okay? So is N your choice? No. Is M your choice? No. We do want L, okay? What's my new L coordinate? 0, negative 3. My old L is 0, negative 2. Again, does 0 divided by 0 help us at all? No. Okay, so we want to take negative 3 divided by negative 2, which is, you could say 3 over 2 or 1.5. Okay, so if you put 3 over 2 here or 1.5, that works too. Okay, again, these two statements should coincide with each other. They should match up. Capiche? All right. All right, so last transformation we're going to talk about is dilations. So label the back side of your paper dilations. Okay. With reflections, translations, and rotations, all of them had something in common. What were they all? Something about moving. What type of motion were they? Rigid motions. What does a rigid motion mean? Stays the same size and shape. Okay. Is that going to be true for dilations? No. What is a dilation? What's happening? It gets bigger or it gets smaller. Okay, so is a dilation a rigid motion? No, not a rigid motion. Why is it not a rigid motion? Because it changes the size. However, the shape is still the same. Okay, so it's not a rigid motion because it is not the same size. However, it is still the same shape. Okay, so dilations is kind of the oddball out of the 3, or of the 4. Okay, the other 3 are rigid motions. Dilation is not a rigid motion. 2 different types of dilations. Okay? There are 2 options for a dilation. One is getting bigger, another is getting smaller. But there's specific words for those. Does anyone know the specific wording? One starts with E, one starts with R. Enlargement, what'd you say? Reduce, reduction. Yep. So, for the types of dilations, enlargement means gets bigger. And reduction means it gets smaller. So when we get to describing and or writing rules of dilations, we're going to use those 2 terms, enlargement or reduction. Okay? Those 2 terms also tell you what's going to happen to our image. Okay? So with the enlargement, so looking at, go ahead and flip your notes over real quick. Go ahead and flip back to the back of your notes. That number that you saw in all those, that is considered the scale factor. Okay, the scale factor tells us, 1, if it's getting bigger or getting smaller, and by how much. Okay?
So negative, it goes down.
Good question. Scale factor will never be negative. Yep. Scale factor will never be negative. So for scale factor, I'm going to call that S for now. So if S is bigger than 1 or if S is greater than 1, what do you think that is? Enlargement or reduction? That's an enlargement. If S is less than 1, what do you think that is? Yep, reduction. And then there's one more case. So we have S is greater than 1, S is less than 1, S is equal to 1. Well, what happens if S is equal to 1? Stays the same. Yep. So to perform dilations and to write rules of dilations, the scale factor is the most important part. Okay? Scale factor is what tells us if it's an enlargement or a reduction, and it tells us by how much it's getting bigger or getting smaller. Okay? So go ahead and flip to the front of your notes. We're going to do a lot of flipping back and forth. Okay? Now that we've talked about all the pieces, we're going to talk about performing the dilations. Okay? There's two things we look at when we're performing dilations. Okay? One, you look at if it's going to be an enlargement or reduction, because that will tell you if it's going to get bigger or it's going to get smaller. You can use that as a checkpoint. Okay? When we're performing the dilations, we have our original XY. What's the original image called? Pre-image. Yep. So we have our pre-image. I'm going to write it in mathematical terms at the top and words at the bottom. Okay? So we have our original XY. How do you think we perform the dilations? How do we use the scale factor? We're going to multiply, right? We're going to multiply by S, which is the scale factor. So down here, multiply by the scale factor. And that's going to equal our X prime and our Y prime. What do the prime symbols indicate? That's the final one. What's the final one called? Image. Yep. So we take our pre-image coordinates. So we're going to take each coordinate separately. Take the pre-image coordinates times the scale factor, and then that will give us our new image coordinates. Okay? So keep this in mind. Let's go back and do an example. So notes. Let's take some notes on that part. Okay? I want to clarify something real quick. Remember, when you're multiplying this, think of the distributive property. It goes to both coordinates. Okay? So, writing the rule. There's two things we need. One, we need to say whether it's an enlargement or a reduction. So we need to say it's getting bigger or getting smaller. What do we have to make sure of first before we can decide if it's an enlargement or reduction? Not yet. What'd you say? What one's the original? Okay, we have to go from pre-image to the image. Okay, so always making sure you start at that pre-image, just like we did with reflections and translations and rotations. Okay, that part never changes. The second thing we need is what? You all said it. The number, right? What's the number called? Scale factor. Okay, we have to find the scale factor because, yes, we know if it's an enlargement or reduction, but we need to know by how much. Okay, does anyone have an idea of how we can find the scale factor given the two images? What'd you say? You could visualize it. How can we do it mathematically? What'd you say? We are going to divide. We are going to take our pre-image. Nope, I lied. Our image divided by the pre-image. So if it helps you think, new divided by old. How do we know which is which? Which one's the prime? Yep. New is with the prime symbol, and then the old is the original letters. Okay. Flip your notes. Let's go try an example. Number